Uttara ma'am will felicitate.
Okay. Thanks.
Dr. Varuni ma'am, a dedicated scientist and passionate science outreach person. Thank you ma'am for graciously accepting our invitation. Dr. Varuni ma'am serves as a project scientific officer at IMSc coordinating scientific outreach initiatives for past 8 years. Almost for past 1 decade, IMSc has been organizing Science at the Sabha, an annual public science event. Dr. Varuni has been the backbone organizing this unique event. Currently, she is actively involved in the Vigyan Pratibha project, which aims to nurture and deepen mathematics and science learning in government schools. Her commitment in fostering scientific curiosity and engagement among students, teachers, and general public has made a significant difference in bringing science closer to young minds. Today, she joins us to share valuable insights on teaching learning resources from HBCSE TIFR, a session that will undoubtedly provide us with innovative approaches and strategies to enhance science education. I once again welcome you, ma'am.
Thanks.
The stage is yours.
Yeah, thank you. Sorry. I'll use this mic, I think. Is this? Yeah, it's okay. Yes. Okay. I might need to charge this also. Sorry. I might need to charge this also. No problem. In the papa, it will come that side. Thanks. Okay. Can you hear me? Yes. Can you still hear me in the back? If I no, okay, use the mic. Okay, I'm just checking. Just checking. Okay. Okay. So it is a very difficult spot to be in because I am the only person between you and lunch. So we'll try and do some fun stuff. Okay. So I'll start off with a small puzzle. Okay. So if you remember these, some of you might remember that there used to be these in stations to buy platform tickets. There used to be those vending machines. Do you sort of remember? So let's think about, imagine one of those vending machines, and the machine only takes 1 rupee and 2 rupee coins. Okay? Yeah? So, and let's say the costing for one platform ticket is 1 rupee. And it only takes 1 rupee and 2 rupee coins. It doesn't give you change, it doesn't do anything. Yes? Clear? Okay. Now, if I have to buy one platform ticket, how many different ways can I put money in? Only one, right? So I just put 1 rupee and I get one platform ticket. Yes? Now if I have to buy 2 platform tickets, what are the different ways I can do it? Louder, louder. Huh? Sorry? You can put 2 rupees. You can also put 2 1 rupees. Correct? So let's write this down.
You can use this mic also.
Okay. But you can hear me, no? If you can't hear me, just... Okay. So for, let's say... So is this okay? Shall I make it? I'll make it a bit bigger. Yes? Visible? Okay. So so number of platform tickets, for one platform ticket there's only one way to do it, and it's just 1 rupee, right? So what? Oh, okay, sorry. Yeah. So what about for 2 platform tickets? What did we decide? 2 ways to do it. What are the 2 ways? Sorry, 1 second. I don't know why it's doing this. Just let me make sure the text is okay. Anyway, with this, yeah, okay, perfect. So so I can do it like this, right? and then I can also just do a 2 rupee. Is the notation clear? What I'm doing? Yes. Okay. Okay. And so the number of platform tickets, and then finally the number of ways, right? So how many number of ways can I pay for one platform ticket? Let me do it this way. Okay. So the number of platform tickets, number of ways. No. So these are the ways. Sorry. And number of ways. Okay. So there's only one way. How many ways are there here? Two ways. Okay. So now what about 3? How many ways? What are the different ways? Let's start writing them out. 3 1 rupees. Okay, so let's write that. Okay. 1 rupee and 2 rupee. Any other ways? The order doesn't. Let's not bother about the ordering. Any other ways? No, no other ways. That will become 4 rupees and it doesn't give you change, right? So you can't do that. So how many ways are there? 2 ways. Okay. So now what about if I need to buy 4 tickets? Okay. So we can put this same thing. Okay. What else? 2 rupees. Okay. Okay. So you can do 2 and 1 and 1. Any other ways? No other ways? Okay. So totally 3. What about 5? Do you want to guess how many ways there are? Okay. 4 ways. Can you write? Can you all just write them down and then you can tell me. Just write down what are the 4 ways. If you think there are 4 or 5 or 6. Three ways. Okay. What are the 3 ways? Tell me. Okay, 5 1 rupees. Okay. 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 Any other ways? Any other ways? Oh, sorry. Yeah, you're right. I know what you mean. Okay. Any other ways? No, you're not allowed. It only takes 1 rupee and 2 rupee coins. Okay. What if order did matter? Then can we do more? Where's my 4? Okay. But you're sure without order there are no more of these? Okay, so if order did matter, for 3, what is the other one? I think ma'am said one way, which is this 2, 1. Okay. Now what about this one? Are there more? So now let's say there are 3 ways. What about for this one? How many ways are there? Okay, so let's write those out. What are the other ones here? 1 2 1. Okay. Okay. Any others? No? Okay, so now there are actually how many ways for 4? 5. What about this one? 6 ways. Okay. Shall we write down the 6 ways? Okay. Tell me one more way here that I haven't written. Someone. 1 1 2 1 1. Okay. 1 by 1. 1 1 2 1. Okay. What did you say? Okay. Any other ways? Hmm? Okay. Any other ways? Okay. Any other ways? 2, 2, 1, 2, right? Okay. Any others? No? So how many ways are there? Hmm? How many ways are there? Okay. 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 So do you see any pattern here? Are you noticing any pattern? Okay. 111 is coming, okay. Any other patterns? I'm talking about a pattern in this column. Do you notice any pattern in this column? So someone said Fibonacci. Okay, so you recognize that it. Have you heard of what a Fibonacci series is? Yes, you want to tell us, sir?
If you add two, then that one will come. The two previous sequence of the sum of two.
Okay, so every number is you can get every number by the sum of the previous two numbers, right? So if you look at 3, it's a sum of 1 and 2. If you look at 5, it's a sum of 2 and 3. If you look at 8, it's a sum of 3 and 5. So what do you think the next one is going to be? I mean, what is the next one? 13. So can you try and write out 13 unique ways to do this? Can everyone write it down? Okay. Ma'am said that these all. Then she said, someone said 222. Okay. Others? Double two, double one. Okay. Hmm? 2, 1, 2, 1. Okay. So how are you coming up with these? What is the strategy? Can someone tell me what is the strategy that you are using to come up with this? What are the strategies that you are using to come up with this? Anyone? We haven't got to 13 yet. Is it not 13? Maybe it's not a Fibonacci sequence. Any other ways that you can get to 6? So there are only 1, 2, 3, only 6 ways. Sorry? 4 ones and then 2. Okay. Okay. 1, 2, 2, 1. Does that do it? 6? Yeah, okay.
1, 1, 2, 1, 1.
Okay. Okay. Any more? 6, 7, 8, 9, 10. Sorry? 1, 1, 2, 2. Okay. Is that 13? Are we missing anything? 1, 1, 2, 1, 1. Okay. Any others? Are you sure there are no others? Sorry? 1, 2, 3, 4, 5, 6, 7, 13. Triple 1. Okay, that's not here. Okay. Now there's 14. Is there something wrong? The third from last, yeah, you're right. So that doesn't come to 6. So we remove it. Okay. So this is 13. Are there any more? No one can think of any more? Are you sure there are no more? How can you be sure? Which one? Tell me. This one? And which one? 1, 2, 3, 4, 5. Oh, from last 1, 2, 3, 4, 5. Yeah, okay. So that is removed. Okay. So now there are 12. So are there any more? Okay. 1, 2, triple 1. Okay. So now we are back at 13. Are there any repeats now? Are there any others? Are there any more? Is there any way to make sure that there are no more? Okay. Let's leave it at 13 and see whether later we can find. What about 7? How many are there for 7? Sorry? Okay, so ma'am is suggesting maybe it's 21. But that's just because you've seen the pattern. But why does the pattern work? Can you think of that? So why don't you start writing it down for 7? Okay, we'll give you a few minutes. So how many ways can you make 7? Okay, have you found 21? All 21. So find all 21. Try to write down all 21. Think of what strategy you would use.
Use addition.
You can use addition. What do you mean by that?
2 into 1 plus 1 into 1. Get 3, 1 more. Third term.
So, explain that. I didn't catch what you meant.
Multiplying and then adding it. Can you use it?
You can multiply. Oh, you mean
2 into 1 is 2. Plus
okay?
2 into 1 is 1. Then it becomes 3.
Okay, but I'm saying when you're writing out the 21 different ways, how would you think of doing that? It might be tough, but there is some information here that you already have. What do you already know? When you are trying to write 7, the different ways to make 7, what do you already know? What have we already written? We have up to 6. Okay, so how does that help us? Yeah, so you can take 6, right? The set of 6, and you can add 1, right? Because that becomes 7. So you can take this whole set, right? And you can add one more 1 rupee coin, and that is one full set. Correct? Now what is the second set that you can use? Correct. 5 lepoite, you can take this 5 and add 2. Right? So basically what you do to get 7 is you take whatever I had written for 6, right? So I'll call it like this. Whatever I've written for 6, right? And you do that and you add 1. Right? Sorry, I'm just making up this notation. I hope it is clear what I'm doing. Okay, so whatever I have done for 6, I take all of those and add 1 at the end. Right? And then I also take whatever I have done for 5 and what do I add to that? Whatever I have done for 5 and what do I add? Add 2. Right? So now how many ways are there? How many ways were there for 6? How many ways were there for 6? 13, right? So, this was 13. Okay, so I have the number of ways for 6 and then what else? How many ways did I have for 5? 8. So then I add that and I add this, right? And this should be 13. And you get, right? So now what about 7? How do I make, 8. What would I do for 8? The number of ways I found 7, which is 21, right? And then I would take whatever ways I had for 6, right? And then add 2, right? So, okay. So it is actually the Fibonacci sequence, right? So we did guess it right, but we also were able to show why it is that. Just seeing the sequence is one thing because you don't know if you keep going, maybe some other number is going to show up, right? So if I only had given you the first 3, right? You might, if you only saw these 3, you might think that it's just 1, 2, 3. Like, so you might think 4 is just going to have 4, but we saw that that's not true. Okay, so this is just a small one of the puzzles that is there in this unit. So I'm going to show you the unit. So don't worry about writing down these names or taking pictures because I will send the list to Uttara and she can share it with you. So this is a program that I've been working with. It's called Vigyan Pratibha. So what we do is we work with government teachers, both central and state, and we make resources that they can use with middle school teachers. So middle school is like 8th standard to 10th standard. And this unit, this example, this puzzle that I just showed you is the beginning of a unit on Fibonacci series. So I'll show you some of these. I'll show you this unit as well as some of the other units. So there's both. It's both there in maths and science. This is a maths unit. So there's stuff for 8th standard. This is actually a 9th standard unit. Yeah. So basically, there are a couple of different examples of how. So everyone might have heard of this Fibonacci series, but students. Just as a series, it might not make a lot of sense. But to talk about where you actually see a sequence like this, for example, in this counting problem, and there are actually a few other counting problems also that this talks about. So this is what we just wrote out, right? Like this table. But you can also see it in the way that bees multiply. You can see it. So you can try this out. This is all online, available for free. I'll send you the links and you can try it out. So this is, so for a bee, there's also, you end up getting the Fibonacci sequence if you try to count the number of these squares, these grids, the number of ways you can arrange grids. And then of course this you might have seen of the sequence. This is one of these spiral things. So it might be a lot of things that students and even you might have seen before, but it these units talk about it in a slightly more rigorous mathematical way, while still allowing students to kind of explore all the different possibilities. So this is the one about Fibonacci. There are others that I will show you. So all this is available online, and I'll show you science. So there is also this unit. So this is a unit that actually Uttara does a lot with teachers. So it's about how you can look at how diffusion happens. So diffusion is a concept that might be hard to communicate with students. So a lot of the science units try to give you hands-on experiments that the students can try. And you can try them also. They're quite fun and they're easy to do. And these, some of these units actually, Uttara and my colleague Mani have been involved in translating to Tamil. So there are actually bilingual versions for a lot of this material. Some of the other stuff they are still working on the Tamil version, but yeah, I'll give you. So this is a unit that tries to look at diffusion and how you can do some simple experiments just with agar. Jello. Have you seen Jello? So you can just use. You don't even need any fancy laboratory equipment. You can just use like small kinums and Jello and like try this stuff. So these units are also, so the version I'm showing you is the student version, but there are teacher versions which also have notes for the teacher in terms of what the students might answer and how you can respond to it. So these are the actual. So you can take different shapes and have dye in it and see in which shape the dye kind of goes out the fastest. And this has to do with basically surface area. Since you're physics students, you will know this. It's not a spoiler, hopefully. Okay, so this is a unit about shapes and diffusion. We also have these units called local context, which are units that are about they're different from place to place. So there is the one about rice, which talks about the different varieties of rice. So depending on which school you do it in and where that school is or where the students come from, they might have different rice that they use at home. This is a very nice unit that I recommend you all look at. So it's about birds. So this has a Tamil version also. So this is not the version I want to open. Okay. Anyway, so there are all these pictures of birds that come from students themselves. There are many ways that there are sort of. This is not the version I want. Anyway, okay. So it tells you more about how to draw birds and how to observe them, see what they are doing. So you might think that I live in a city. What is the bird that I don't see any fancy birds. But in fact, if you kind of are observant, you will see a lot of interesting things about birds. So depending on what they're doing, how they're sitting, like what are they eating? Are they interacting with other birds? What kind of feathers do they have in what season? So there's a lot of things that you can actually observe even just in your own school, your own college. So this talks a little bit about that. Okay, so you can explore more about this. There are a lot of other units. You're mainly physics students, right? Physics or maths also? Physics, maths? Physics? Okay. So so there is this unit which is about so anyway, you can go through the units. I won't go through all of them now, but this is one resource. And like I said, a lot of the material that is in the 8th standard, both in maths and science, has versions in Tamil as well. And this Uttara and my colleague Mani have been doing for a while. So this is one. The other The other resource I'll show you, which is for younger children for primary school, is called Small Science. So this is also something that was developed at HBCSE, which is Homi Bhabha Center for Science Education. It's one of the, so Vigyan Pratibha is also centered there. So it's one of the few places in the country that does education research. So they have a PhD program where you study how students learn at different levels, at school level, at college level. So how do they learn? How do they think about things while they are learning? So it's one of the few places in India that actually has a PhD that has to do with education. This is another, and all of their stuff, it's a government institute, it's a central government institute, so all of their material is available online for free. Like I said, the Vigyan Pratibha material is all available for free. And then this is Small Science, which is for primary school. The Tamil version is up. So this also, there is a Tamil version now, which Uttara and Mani were involved in translating. So this is this is for 1st to 5th standard. So there are a lot of these small units about how young children think about like playing, running, different things that they see around them. So this is another sort of resource that you can look at. It's called Small Science. I'll send all these links to Uttara and then she can share them with you. So it's there in English also, but I thought I'll show you the Tamil version. Okay. In case you guys are going to sleep, we shall do one more one more quick activity. So this is also a group that's at Homi Bhabha Center. So it's called Design, Technology and Education Group. So they think about how design affects how you read. So if you think about your textbooks, there's a certain way that your textbook is organized. So there is actually someone who sits and thinks about, okay, if I put text here, where should I put the image? How are people going to relate the image to the text? So this is all comes under this larger thing called design, right? So it also is helpful in sort of when you're trying to innovate. This sort of design is very important. So they have a bunch of resources that you can also do. So this you can do at any level, at a high school level as well as even at a college level, or if you're trying to work with your friends on some project. Some of these materials are helpful. So I'll show you one of these resources. So they have these activities that you can try out, and we'll try out one of them together. So there are all these different activities. So these are available currently in Hindi and English. But let me try this activity with you. Okay. So so maybe you can hand out the pencils and erasers. So you can work in while they're handing it out. Maybe you can get into groups of five or six. We'll do this quick activity and then I'll show you a few more resources and then we'll finish up. So while they're handing it out, maybe you can just get into groups of 5 and then after that I will I'll tell you the instructions. I mean, these are the instructions, but I can talk to you about it also. You only need one paper per group. One paper per group. One paper and one pencil per group, that's enough. Okay, ready? Yes? Okay, so first the ground rules. Okay, so everyone, you can show everyone in your group what you're drawing. Nothing is it's everyone's drawing on the same. Everyone in your group is going to be drawing on the same paper. It's not a secret. Everyone can see what everyone else is drawing. Okay. Second thing is you're not allowed to talk to each other though. So you can't say or say like do this like all your dumb charads thing and all you can't do. Yes, clear. Two rules clear. These are the only rules. A few more rules, but still. Okay. Okay. So now what I want you to think about. So who is the first person in each group? The first person to draw something. So everyone's going to get a chance to draw. Each group can one person raise their hand. Whoever has the paper and pencil right now. Yes. You can raise your pencil. Yes. All groups have one person. Yes. Don't make very big groups. I think you guys need to break into maybe 2-3 of you can go in the back group. Yeah. So don't do more than 6 people. Okay. Yes, everyone. Yeah. So I want you to think of one simple instrument that you have in your lab. Any lab. Any lab that you have gone in, that you did yesterday, that you did last year. One simple instrument. Yeah. And the first person, people who are raising their pencil are going to draw that instrument. Okay. It doesn't have to be a very, very fancy drawing or anything. It just has to be a drawing, kind of like a schematic, right? So if I ask you to draw a microscope, you're not going to draw a microscope that looks exactly like a microscope, but you're going to make sure it has all the different parts, right? So a microscope, what are the parts that don't draw a microscope now because I'm talking about it. Draw something other than a microscope. But what are the parts you would draw for a microscope? What are the parts? Microscope we've all seen, no? Okay. Eyepiece. What are the other parts of a microscope? Eyepiece is one. Objective. Other parts. Stage. What else? Yes. So a sort of tube. What else? Maybe a mirror. Sometimes you need light, right? So basically you would draw a microscope that has all these parts, right? But it doesn't have to be exactly looking like a microscope. So like that, think of a different instrument that you have seen in your lab and quickly just draw a schematic of it. You guys are not part of any group. You can be part of this group. I thought we're not allowed to talk. That was rule number 1. Okay, no, rule number 2, but still. And I haven't even told you the rest of the rules yet. Okay, if you finished drawing, if that first person has finished drawing, can you hold it up? Drawing the schematic so that I know that everyone's done. Okay. Okay. This group, 3 more groups we are waiting for. Speakers, are you forming your own group? No. Okay. Okay. One more group. We're waiting for this group, I think. It's okay. Take your time. You're done? Okay. Okay. So everyone has the first drawing. Yes? Okay. So now what I want you to do is pass it to the person next to you. Okay? And they have to use the rubber and rub out one part of it. One part of it. Again, you can't talk to each other. This is supposed to be you talk about it at the end. So rub out any part of it. Okay. If that the second person has rubbed out some part of it, you can raise your paper so that I know you're all done. Okay. This group, that group is done. This group we are waiting for, and that group I think, and the back group. They are also done. Okay. So 2 more groups. One item has been rubbed off with all the groups. Okay. Now pass the paper to the next person, and what the next person has to do is whatever has been rubbed off, you can't redraw it, but you have to draw something that functions in the same way. Okay, so for example, I'll give you an example here. One sec. So I'll give you an example here. So here, this is some sort of microscope, and the first person who took it rubbed out the thing that holds this object, right? So the second person came, and the third person came and drew this. So there is a wire, that the spring that kind of holds this, right? So the third person, once they draw that thing, they also rub out a different part of it. So the third person who took it drew this spring and rubbed out this part of it. Is that clear? Yes? So the third person, if you're done in the group, just raise your thing, raise your paper. When the third person is done, the first person was the person who drew it. Second person rubbed out one thing. Third person drew something and rubbed out something. Third persons are done. Okay. There, she's done. What about you guys? Third person? Third person finished? That group, 2 more groups we are waiting for in this group, maybe. Yeah? Yes? Okay. Now it goes to the fourth person, and the fourth person does the same thing, right? So you have to, whatever the third person rubbed out, you have to replace it with something else that does the same function, and you can rub out something else. So just continue this process until you get to the last person in your group, and the last person in your group, they can draw something but don't rub out anything. I give you a few minutes, and then maybe 5 minutes, and then you can share some of your experiences, and then we'll close up. Pass it to the next person. Finished your group. Okay, we'll just wait for a few more. What you drew? What is this? Who's
Sonometer.
okay?
Potentiometer, ma'am.
Okay.
And she rubbed this part and
Huh.
she drew this wire, ma'am.
Okay.
And she rubbed this part and I drew their knife edge, ma'am.
Okay. Okay. He's becoming something else. What did you start with? A tuning fork. Then what happened?
Yes, actually we start with the screw gauge,
Okay.
then we ends with the tuning fork.
Okay. I meant that. What I meant was the object has to be used for the same thing. Continue to be used for the same thing. So if you rub out something, you have to draw something that does the same function. You can try it once more. Maybe I'll clarify this, and then you can start again. Okay, one quick clarification. So you might want to like start the process again and just do one round quickly. So whatever the previous person rubs out, right? When the next person draws it, it has to do the same function. So for example, this was a stand, right? It was holding something. So when this person rubbed it out, the third person decided to draw like a spring to hold it in the same place. Is that clear? Yeah? Okay, does anyone want to share like what happened in their groups? Any group wants to quickly share what happened in your group? Maybe two groups can quickly share what happened in their group and then we can move on. So any group that wants to tell us what happened, go ahead. Mike. So what happened in your group?
Actually, we saw network magnet.
Okay.
First person remove the metal
Okay.
and he draw sample third person.
Okay.
And he erased the stand and everything. So I draw a coil and a magnet so that it functions well.
Okay. So he got it back to function. Anyone else wants to share?
Good afternoon. First, I draw ammeter.
Okay.
So she erases the reading which I have mentioned.
Okay.
So again, it will measure current only.
Okay.
So the third person changed the reading,
Okay.
and first person given the stand at that side to show it,
Okay.
and the last person changed the ammeter into milliamps. So it
Okay.
will measure in milli.
I see. Okay. So it's the same instrument, but you've changed the measurement and some of that. Okay. So the general idea of this, so you can try this in your either in your groups or in your classrooms if you're a teacher. The idea of this is that it helps people sort of generate creative ideas. So you're all working on the same thing, but you're kind of thinking about it slightly differently. So I'm sure in college you've all been part of group work, right? Like group projects. So a lot of the group projects work because, someone comes up with some idea, another person says, no, that's not that good an idea, let's try something else. And the third person will say, no, that's good, but let's try something else. So this activity kind of helps you think of that for design. Yeah. Okay. So I just wanted to give you a flavor. This is a small activity, but there are a lot of these sort of activities here. And especially for students, some of these are quite fun. So there's this spice box challenge. So they're all kind of small activities. And you can look at them and kind of go through. There's also a little note about pedagogically why this is important, right? But a lot of it has to do with design. So this is one other resource I wanted to show you. There are a few other things, 2-3 magazines also. These are not from HBCSE, but this is from APU, so Azim Premji University, which is in Hosur, a little bit Sharjapur, outside Bangalore. So they have these 2 magazines. One is called I Wonder. It comes out every 4 times a year. These magazines are free. You can download the whole magazine on their webpage. They have, and if you write to them, if you email them, they will send you the magazines to your school library, to your house, to your friend's house for free. So you just have to write to them. And anyway, the full version is available online. So there's a lot of you can contribute to these magazines. So if you do something interesting in your class, you can always contribute to it. But it's a great resource for activities that you can do in class. It's a heavy file, so sorry I didn't download it before because I wanted to show you the web page. Okay, so while that happens, they also have a maths magazine which is called At Right Angles. That comes out, I think, every month. Yeah. No, that also comes out once every 3 months. This also, it's the same thing. You can just go to their webpage, download the whole issue and read it. If you write to them, they will send you a copy to your library or to your school or to your class. So, and they are also so the other thing is, a lot of these things, people put in a lot of work into how they are designed, and that makes it really fun for students and easy for students to find things. So see, each of these, like for example, this thing on top is a design element that people use. So that's one of the things that's also important. So you can look this up. This has a lot of activities. I was going to go through one of these activities, but I think we don't have that much time. So this is the science one. This actually has a whole bunch of daytime astronomy equipment. So this is by who? Yeah. So you can take a look at this, and a lot of the material that they use to do all of this is not very much. So you can kind of do it with your students, do it with your friends, things like that. Okay, so these are the two magazines. There are a few other associations. So there is this Mathematics Teachers Association. So this is a association. It's you can just go and become a member if you like. But they have these regional meetings. So I had gone to this meeting in Kochi last year. It's a very nice group of teachers. They share what they've been trying in their classes. And this is mathematics teachers, from school to college to professors. So just mathematics teachers, and it's a lot of sharing of what kind of stuff they are doing in their classrooms. Maybe some of you would like to try it also, some of the teachers. So that is, again, I'll send all these links to Uttara so that she can also send them to you. But I just wanted this is a new thing that, we're trying to kind of do. There is this MTTS program. So this might be something that is interesting, especially for the college students. These are these workshops that are again run regionally, and you can apply for it. And a lot of the institute that I work at, IMSc, many of our PhD students sometimes teach in these programs, but a lot of the PhD students who come to our institute also come because they've attended programs like this and learned more about mathematics. So you can look at the web page. Like, they have regional workshops, so they'll have one in Tamil Nadu at some point. But you can look at this list of like various different things. There is this other program which is called Vigyan Vidushi. So this is again for college students. So there are a lot of these programs in various institutes that you can apply for. And the applications are quite simple. Like, it'll just be like, what is your interest? Maybe it'll ask you for your mark sheet or something. But these are very, you get a lot of exposure in these programs because professors and graduate students from premier institutes will usually come teach at these. So this Vigyan Vidushi program is for women, and they have it in physics, chemistry, computer science, and mathematics. It's a 2-week program in the summer, and it's at TIFR Mumbai. And there are professors from all over the country in various research institutes who come and teach at this program. So if you're sort of interested in mathematics research or physics research, these are very good programs to attend. You also get to meet a lot of other people from different parts of the country who are also interested in maths and physics and research. And usually a lot of these programs will cover your, once you apply, it will cover your accommodation, travel. It takes care of all of that. So you don't need to pay for the program. They are entirely free programs. It's just a matter of applying for them. So if you're interested to apply to any of these, you can talk to me. You can talk to ma'am. Ma'am also probably knows some more of these programs. So IMSc, so the institute I'm at, which is the Institute of Mathematical Sciences, we also have a summer research program. So if you apply, I think the applications are being taken right now. Just check. The applications are closed. But so in about, if you look in December or January, you can apply. basically saying I'd like to do research or I'd like to do a reading with a professor, and you get a small stipend, and you can spend a month working with someone at IMSc. So you can look at this summary. And so IMSc has one, but most research institutes have similar programs where you can go and work with a professor for a month, especially over the summer. So you can look at, if you're interested in biology, you can look at NCBS, which is a biology institute. If you live in Bangalore or maybe want to be in Bangalore for the summer, there's ICTS, which is another, or IISc. All of these have some sort of research program, and it will be there on their website. And none of these are going to be, like, you don't have to pay for any of these. These are usually at government institutions. They're free. In fact, if most of them will pay you. So look, if you're interested in research, this is a great way to try to start understanding what research is, and if you might be interested in getting a PhD or going into research. So these are great ways to kind of explore that. Any questions about this? Any questions, comments? I'll be ending in a few minutes. Any questions about any of these resources or opportunities? So HBCSE, which is Homi Bhabha Center for Science Education, I'll show you their webpage also. So HBCSE also will have a summer program. So especially if teachers, if you're interested in, they will have a summer program. I found it yesterday. Anyway, I can find the link and send it to you. So they do research in education. They try to understand how students learn, especially in the sciences and mathematics. So if you're interested in something like that, something more pedagogical, they also have summer research programs, which means that either as a teacher or a BSc student, you can apply to go work with someone there for a month to understand what kind of research they do. So you can look there. There will be a summer, like visiting fellows and summer. So you can, if you're interested, I'll find the exact link and send it through Uttara. Okay. Any other questions, comments? So this is HBCSE is one of the few institutes in the country, like I mentioned, that does this kind of education research, which is in a very important field of science to understand how to teach, and what teaching is effective and what will help a child. Any questions, comments? No? Okay, then I will sort of not stand between you and lunch anymore, but I will shamelessly promote this. So this is our largest public science event that is coming up. I think Uttara, the person who introduced me, mentioned it. It's called Science at the Sabha. It is on this Sunday. So all of this science, and all of these researchers that I was telling you about, 4 of them will be at the Music Academy giving talks. I will show you the poster which has the QR code, so you can register and send it to your friends. So it's 4 talks on science for the general public. You don't have to be a physics student to understand it. You can bring your mother, you can bring, whoever you want. It's very general talks just for people to understand how science, what scientists do, and what is the process of science, and what is ongoing cutting edge research that is happening in India right now. So I think with that I will sort of finish, unless there are any questions or comments. I think I'm done. Okay, thank you. Thanks. I'll leave this on so you can register. No, that's all. I'm done. You can give me that. Thank you. Thanks. Oh, this mic. I thought you were giving me a mic. Thanks.
Now, our assistant professor, Dr. Sangeeta ma'am, will present a certificate to Dr. Varuni ma'am. Thank you, Dr. Varuni ma'am, for your time and knowledge. Dear participant, we will have our lunch break in physics department where you did yesterday. I request everyone to assemble here before 3 p.m.